Hello guys, welcome back. This is Mathrick. If this is the first time you've come across with this channel, make sure to subscribe and turn on the notification bell for the next time you see the new update. And today's lesson we are looking at the conversion of decimal to binary number via octal. We have a questions written down here. We have 37 14 to the base 10, and for question 2 we have 0.5 0.5935 to the base 10. So what you have to do, you have to take these numbers into base 2. That's when you can take it. That's when you can convert it to octal numbers. So let's get started. For solution, we have this one here. So what you have to do, because we are converting via octal, it is made up of base 8. So you have to divide this number repeatedly by 8. So let's get started. We have let's use we have for 1 we have 37 14 the base 10. So we have to use this way, which is this way. We have 8 because we are converting via octal. So 37 14. Here we have to write the remainders. Divide 8 into 37 14. The answer you get it is 464 with a remainder of 2. Then 8 into 464, we are going to have 58 with a remainder of 0. Then 8 into 58, the answer it is 7 with a remainder of 2. Then 8 into 7, it can't, so in which it will be a 0 here. We carry the 7 to this number here, in which we are going to get the answer starting from down going up. So let's get our answer here, in which we have 7202 to the base 8. So we have taken it to base 8. So we have converted from base 10, from this base 10 to base 8. So we have to convert this answer to base 2. So how do you convert this number into base 2? There is a table which you must know by heart, which has a content. We start from 0. We start from 0 to 7. So you have to draw this table. The table goes like this one. So here we have octal digit, and the natural of 0. Then natural binary code, you are going to have 0 0 0. Then if you have 1, then you are going to have 0 0 1. First of all, let's write these numbers: 0 1 2 3 4 5 6 7. So if you did Boolean expression, this is where you 4 zeros, you write 4 zeros. Then here you write 0 0 then 1 1, then here 0 1 0 1. Then if you are done with 4 zeros, you write 4 ones here. 4 ones, you are done. Then here you have 2 ones, you write 2 zeros, 2 zeros. Then you followed by 2 ones. Then here the process goes like this one. We have 0 1 0 1 0 1. So this is a table to follow for you to solve octal numbers, in which this one here we have 70 2 0 2 to the base 8. If you take it into base 2, it will be 7. We have 3 ones. If you can see 7, we have 3 ones. So you put 3 ones here. 3 ones. For 2 we have 0 1 0 0 1 0. For 0 we have 3 zeros, 3 zeros, 3 zeros here. Then for last 2 we have 0 1 0 to the base 2. So this is our answer for this question here, by converting a decimal to binary number via octal numbers. So let's look for question 2 now. So when you are converting a decimal numbers in base 10, you multiply this number by 8, because we are taking it into 8. That's when we take it to base 2. So we multiply by 8 this number. 8 multiplied by 0.59375. The answer you get it is 4.75. So the remainder which we have, it is 4. So here it is 4. Remainder which we have, this is our remainder. Then we are going to multiply 8 by 0.75, because we have removed 4. This is our remainder here, in which we are going to have 6.0. So 6, it is our remainder here. And this is where this question ends, in which we are going to start with 0. Then we start, when getting the numbers, you start from up going down. It's different from that one which I did at the first, in which it will be 4 4 6, the base 8. So we have taken it to base 8. So now let's take it to base 2. How do we take into base 2? We have to follow that table which says 0. Where this 4 is showing that we have 1 0 0. For 6 we have 1 1 0, the base 2. So this is our answer for question 2. Thank you for watching.